Google's quantum AI scanned 3-eye atlas images, and the results are nothing short of terrifying.
When Google's quantum AI got its hands on telescope images of the mysterious object racing toward Earth, nobody expected what came next. The advanced AI systems, designed to spot patterns humans miss, started flagging something deeply unsettling in the data. What should have been routine analysis of another space rock turned into something that has astronomers quietly concerned. The readout suggests we're not looking at your typical comet, and if the AI is right, we might want to start paying very close attention to our unexpected visitor, the discovery that changed everything. July 1st started like any other day for astronomers in Chile, but what they discovered that morning would send shockwaves through the entire scientific community. Hidden among the data from the robotic ATLAS telescope was something that shouldn't exist: a tiny glowing dot racing through space at impossible speeds. This wasn't just another asteroid or comet drifting through our cosmic neighborhood. This was something from beyond our solar system, and it was heading straight for us. The object appeared as nothing more than a speck of light against the backdrop of distant stars. But what made scientists drop their coffee cups was the speed. This thing was moving at over 130,000 miles per hour, covering distance so fast it could travel from New York to Los Angeles in just over a minute. To put that in perspective, a commercial airliner takes about 6 hours to make that same journey, but this mysterious visitor could do it in 67 seconds flat. Within 24 hours, NASA's best minds were running calculations around the clock, and what they found confirmed everyone's wildest fears and hopes. The object had indeed arrived from interstellar space, from somewhere among the stars beyond our solar system. At the moment they spotted it, this cosmic wanderer was already within Jupiter's orbit, roughly 327 million miles from Earth. But by the time you're hearing about this story, it has already covered much of that distance and is now approaching Mars. The scientific community gave it a name that reflected both its origin and its significance: 3E Atlas. The number 3 indicated this was only the third interstellar object ever recorded in human history, following the mysterious Oumuamua in 2017 and Comet 2 I/Borisov in 2019. But unlike its predecessors, this new arrival was bringing with it questions that kept astronomers awake at night and had some of them wondering if we were witnessing humanity's first contact with alien technology. What made this discovery even more unsettling was how late we spotted it. The object had emerged from a particularly bright region of our galaxy, where the dense concentration of stars had masked its approach for years. By the time we noticed it, there wasn't enough time to prepare a proper scientific mission to intercept it. It was almost as if something didn't want us to see it coming until it was too late to do anything about it. A speed and size that defied all logic. When scientists first calculated the true dimensions of 3E Atlas, the numbers seemed so outrageous they double-checked their math multiple times. While Oumuamua had been roughly the size of a football field at about 330 to 380 feet long, this new visitor was hundreds of times larger. Early estimates suggested its diameter could reach 6 to 9 miles across, making it comparable to the size of Manhattan Island. Imagine the entire island of Manhattan hurtling through space at 36 miles per second, and you begin to understand why this discovery kept scientists up at night. The speed alone was mind-bending. At 36 miles per second, 3E Atlas was moving so fast that even the sun's immense gravitational pull couldn't capture it and keep it in our solar system. This velocity was roughly twice as fast as most known objects that call our solar system home. For comparison, Voyager 1 one of humanity's fastest spacecraft, would look like it was standing still next to this interstellar speed demon. But size and speed were just the beginning of the mystery. The object's trajectory through space seemed to follow an impossible path that had astronomers scratching their heads and checking their calculations over and over again. Most objects from interstellar space follow predictable paths based on gravitational influences and momentum. They typically zoom past us in relatively straight lines, maybe getting pulled slightly by the sun's gravity before heading back out into the cosmic void. 3E Atlas was doing something completely different. The path it was following would take it on a grand tour of our solar system's inner planets. First, it would pass within 17.5 million miles of Mars on October 2nd. In cosmic terms, that's practically a close encounter. Then it would reach its closest approach to Earth on December 19th at about 167 million miles away. After that, it would swing by Venus at just 60 million miles and finally make a return pass by Jupiter at only 33 million miles from the gas giant in 2026. What made this trajectory so extraordinary was the mathematical probability of it happening by chance. Scientists calculated that the likelihood of an interstellar object naturally following such a perfectly aligned route with multiple close planetary encounters was less than 0.005%. In other words, in 99.995% of cases, a random interstellar visitor would just zoom past without coming close to any planets at all. The fact that 3E Atlas seemed to be following a deliberate path that would give it front row seats to observe multiple worlds in our solar system was enough to make even the most skeptical scientists wonder if they were looking at something artificial. The trajectory that seemed too perfect. Harvard astronomy professor Avi Loeb and his colleagues spent weeks analyzing every aspect of 3I Atlas's flight path, and what they discovered sent chills down their spines. This wasn't just any trajectory. It was what space mission planners would call a perfect grand tour route. If human scientists were designing a probe to study as many planets as possible in our solar system, they might choose a path very similar to what this object was following. The precision was unsettling. 3 Atlas would pass close enough to Mars to conduct detailed observations, then sweep by Earth at a distance that would allow comprehensive scanning while remaining safely out of reach. The Venus flyby would bring it even closer to that world, and the final Jupiter encounter would provide a gravitational slingshot that could potentially alter its course if needed. It was like watching a perfectly choreographed cosmic ballet, except no one had written the choreography. What made Loeb and his team even more suspicious was the timing of Earth's closest approach. When 3 Atlas reaches its nearest point to our planet on December 19th, it will be positioned on the opposite side of the Sun from Earth's perspective. This means that while the object will be perfectly illuminated by sunlight, making it ideal for observation, the Sun will be directly between us and the visitor, making it nearly impossible for us to study it in detail. Loeb suggested this might not be coincidence, but deliberate planning, a way to observe us while avoiding our scrutiny. The possibility that this trajectory was intentionally designed raised even more disturbing questions. If 3 Atlas was indeed some form of alien probe, why wasn't Earth its primary target? After all, if the goal was to study intelligent life, wouldn't it make more sense to approach our planet as closely as possible? Instead, the object would pass nearly 10 times closer to Mars than to Earth. This led Loeb to propose a fascinating but terrifying possibility. Perhaps the visitors were specifically avoiding close contact with Earth's inhabitants while still maintaining the ability to study us from a safe distance. There was also the unsettling possibility that 3 Atlas had no intention of leaving our solar system at all. Using advanced gravitational maneuvers around Jupiter or the Sun, the object could potentially slow down and enter a long-term orbit that would allow extended observation of our worlds. Such techniques, known as Oberth effects, are commonly used by human space missions to alter trajectory and speed using planetary gravity combined with propulsion systems. If an alien civilization had mastered interstellar travel, they would certainly be capable of such maneuvers. The timing of when 3 Atlas began its journey toward us was perhaps the most chilling detail of all. Calculations showed that at its current speed, the object would have crossed the outer boundary of our solar system approximately 8,000 years ago. That time frame coincided with a period of remarkable change on Earth, when humanity was just entering a phase of rapid development with the emergence of early civilizations, writing systems, and large settlements. The possibility that these developments had somehow attracted attention from across the stars was both thrilling and terrifying to contemplate. When the universe becomes a dark forest. The implications of 3 Atlas potentially being an artificial object led some scientists to consider one of the most frightening scenarios in all of theoretical astrophysics, the dark forest hypothesis. This concept emerged from attempts to answer Enrico Fermi's famous question from 1950: if the universe should be teeming with intelligent civilizations based on probability and statistics, then where is everybody? The dark forest theory provides a chilling answer that makes the arrival of any interstellar visitor a cause for serious concern. According to this hypothesis, intelligent civilizations do exist throughout the universe, but most of them remain hidden out of necessity. They've learned through bitter experience that revealing their presence to other civilizations is often a death sentence. Like animals in a dark forest who risk being eaten if they make noise or reveal their location, cosmic civilizations have learned to stay quiet and hidden to avoid detection by more powerful and potentially hostile species that might view them as either threats to be eliminated or resources to be exploited. If 3I Atlas truly was a spacecraft from an extraterrestrial civilization, its very presence suggested that its creators possessed technology far beyond anything humanity had achieved. The ability to travel between star systems implied not just advanced propulsion systems, but potentially weapons and capabilities that existed only in science fiction movies. Even if this was merely an automated reconnaissance probe with no living beings aboard, the fact that Earth might have been detected and catalogued raised the most unsettling question of all. What were the intentions of those who had found us? The dark forest scenario painted a grim picture of what might happen next. If humanity had been discovered by a more advanced civilization, we faced several possible outcomes, none of them particularly pleasant. Best case scenario, we might be deemed too primitive to pose any threat and simply ignored, like insects beneath the notice of a giant. Worst case, we could be viewed as a potential future threat that needed to be eliminated before we developed the technology to become dangerous competitors for resources or territory. There was also the possibility that we had been detected much earlier by another interstellar visitor that had prepared the way for 3 Atlas. The mysterious Oumuamua that passed through our system in 2017 had exhibited many of the same strange characteristics as the current visitor: unusual trajectory, impossible acceleration, and complete lack of the typical features expected from natural objects. What if Oumuamua had been a scout probe sent ahead to assess the situation, and 3 Atlas was the main vessel following in its wake? The size difference certainly supported this theory. Oumuamua had been roughly the size of a football field, perfect for a reconnaissance mission, while 3 Atlas was hundreds of times larger, more like a mothership or command vessel. The timing between the two visits also seemed significant. 8 years separated Oumuamua's departure and 3 Atlas's arrival, perhaps just enough time for information gathered by the first probe to be transmitted across interstellar distances and for a larger mission to be planned and launched. If this scenario was correct, then humanity was no longer dealing with random cosmic encounters, but with a deliberate and coordinated investigation by an intelligence that had been studying us for nearly a decade. The first messenger that started it all. To understand the full implications of 3 Atlas's arrival, we need to look back at the visitor that started it all, the enigmatic Oumuamua that burst into our solar system in 2017 and left astronomers with more questions than answers. When the powerful Pan-STARRS telescope in Hawaii first detected this interstellar intruder, it seemed like humanity's first glimpse of a visitor from another star system would finally provide answers about what existed beyond our cosmic neighborhood. Instead, it became one of the most controversial objects in the history of astronomy. Oumuamua, which means messenger from afar, arriving first, in Hawaiian, lived up to its name by delivering a message that scientists are still trying to decode. The object was discovered when it was already leaving our solar system, moving at incredible speed and following a trajectory that clearly marked it as an interstellar visitor. But by the time astronomers realized what they were looking at, it was too late to study it properly. All they could do was watch it disappear into the darkness while trying to make sense of the limited data they had collected. What made Oumuamua so mysterious was everything it didn't do. Unlike comets, which develop bright tails of gas and dust when heated by the sun, this visitor showed no signs of such activity despite passing extremely close to our star. It also had an impossibly unusual shape, either elongated like a cigar or flat like a pancake, completely unlike any known celestial body. Most disturbing of all, the object had accelerated as it passed the sun, gaining speed in a way that suggested some form of propulsion, yet showed no evidence of the gas emissions that typically cause such acceleration in comets. The lack of a visible tail was particularly puzzling. When comets approach the sun, the heat causes ice and frozen gases on their surface to evaporate, creating the distinctive glowing tails that make them so spectacular to observe. Oumuamua passed just 23 million miles from the sun's surface, close enough to melt almost anything, yet emerged without leaving the slightest trace of evaporation. It was as if the object was made of some material that could withstand incredible heat without showing any effects. Even more mysterious was the object's sudden acceleration. 40 days before its discovery, Oumuamua had completed its close flyby of the sun and then dramatically increased its speed. At its peak, it reached 54 miles per second, 5 times faster than Voyager 1, 11 times faster than SpaceX's Starship rocket, and 250 times faster than the speed of sound. This kind of acceleration is typically seen in comets when jets of evaporating material provide thrust, but Oumuamua showed no signs of such activity. Something had given it a powerful push, but no one could figure out what. The size and shape of Oumuamua also fit perfectly with what scientists might expect from an artificial probe. Initial estimates suggested it was about 377 feet long and 364 feet wide, roughly the size of a football field. This made it large enough to contain sophisticated equipment and instruments, yet small enough to achieve the incredible speeds needed for interstellar travel. If someone wanted to design a reconnaissance probe to study distant star systems, they might create something very similar to what Oumuamua appeared to be. The fact that this first interstellar visitor exhibited so many characteristics that seemed to defy natural explanation set the stage for everything that followed. When 3 Atlas appeared 8 years later with its own set of impossible features, it was hard not to wonder if the two objects were connected. perhaps part of a coordinated exploration program designed to study our solar system and catalogue its inhabitants. The great scientific debate. While some scientists like Avi Loeb remained convinced that both Oumuamua and 3E Atlas represented evidence of alien technology, the broader scientific community pushed back with alternative explanations that attempted to keep both objects within the realm of natural phenomena. The debate that followed revealed just how difficult it can be to distinguish between the truly extraordinary and the merely unusual when dealing with objects from beyond our solar system. Most astrophysicists argued that what appeared to be evidence of artificial origin could be explained through exotic but natural processes. For Oumuamua, several competing theories emerged to explain its strange behavior. Alan Jackson and Steve Desch from Arizona State University proposed that it might be a fragment of frozen nitrogen broken off from a Pluto-like planet in another star system. As this nitrogen ice heated up during its close pass by the Sun, it could have created just enough thrust through evaporation to accelerate the object without producing a visible tail. Another explanation came from Darryl Seligman of Cornell University and Jennifer Berkner of the University of California, Berkeley, who suggested that Oumuamua was once an ordinary water-rich comet that spent millions of years traveling through interstellar space. During this journey, they theorized, cosmic rays from supernova explosions could have transformed up to a third of its water ice into hydrogen molecules trapped within the remaining ice. When the object warmed up near our Sun, this hydrogen began escaping in tiny jets that provided thrust while producing almost no visible dust trail. For 3E Atlas, skeptics pointed to several pieces of evidence that suggested it was simply an unusually large comet rather than alien technology. Recent photographs showed a faint glow surrounding the object, the kind of coma that forms around comets as they approach the Sun and begin to heat up. While this glow was currently weak, scientists expected it to grow brighter and more obvious as the object continued its approach to our star. The object's brightness also indicated it was likely rich in ice, which reflects sunlight well and would explain why it appeared so luminous even at great distances. Some researchers also detected what appeared to be a faint dust tail extending from 3E Atlas, visible in specialized spectral imaging. While much less prominent than typical comet tails, this feature suggested the object was indeed beginning to show signs of the evaporation process that characterizes comets as they near the Sun. If this interpretation was correct, then 3E Atlas was simply following the same physical processes that govern all icy bodies in space, just on a much larger scale than usual. The size argument also came under scrutiny. While 6 to 9 miles across might seem enormous for a comet, astronomers pointed out that much larger examples already existed in our records. Comet Hale-Bopp, visible to the naked eye in 1997, had a nucleus about 46 miles across. The Bernardinelli-Bernstein comet discovered in 2021 measured an astonishing 85 miles in diameter. From this perspective, 3E Atlas, while certainly large, wasn't unprecedented in size and couldn't be considered evidence of artificial construction based on dimensions alone. Samantha Lawler, an astronomer at the University of Regina who specializes in solar system dynamics, argued that all available data pointed to 3E Atlas being nothing more than an ordinary comet ejected from another star system. She noted that such ejections happen constantly throughout the galaxy, with billions of comets being thrown out of their home systems by gravitational interactions with planets or passing stars. The fact that we were seeing only our third confirmed interstellar visitor didn't mean they were rare. It simply reflected the limitations of our detection capabilities. Yet even among skeptics, no one could fully explain the seemingly impossible trajectory that brought 3E Atlas on its grand tour of the inner solar system. The mathematical probability of such a path occurring by chance remained stubbornly low, hovering around that troubling 0.005% figure. While scientists continued to search for natural explanations, the precision of the object's route continued to nag at even the most rational researchers, leaving room for doubt about whether they were really looking at a cosmic coincidence or something far more deliberate, racing against time to solve the mystery. As 3 Atlas continued its high-speed approach through our solar system, astronomers around the world found themselves in a race against time to gather as much data as possible before the object disappeared forever into interstellar space. Unlike Oumuamua, which had been discovered when it was already on its way out, this new visitor provided a precious opportunity to observe an interstellar object while it was still approaching and at its brightest. But the window for detailed study would be frustratingly brief. The observational campaign began immediately after the object's discovery, with telescopes around the globe being rapidly repositioned to track the fast-moving visitor. Every clear night became precious as teams of astronomers worked around the clock to capture spectroscopic data, measure the object's rotation, and document any changes in its appearance as it approached the Sun. The data they collected would need to last for decades of analysis, as this might be humanity's only chance to study such an object up close for many years to come. What made the observation window even more critical was the object's planned trajectory. When 3 Atlas made its closest approach to Earth in December, it would be positioned on the opposite side of the Sun, making it nearly impossible to observe during its most accessible phase. This timing seemed almost deliberately planned to frustrate human observation efforts, adding another layer to the mystery of whether the object's path was natural or artificial. Astronomers would have only the months leading up to this solar conjunction to gather their most important data. The challenge of studying 3 Atlas also highlighted humanity's limitations in responding to unexpected interstellar visitors. Unlike planned missions to comets and asteroids that can be prepared years in advance, the sudden appearance of objects from other star systems leaves scientists scrambling to make the most of whatever observational tools happen to be available. There simply wasn't time to design and launch specialized instruments to study this visitor. They would have to make do with existing telescopes and hope for clear skies. Some scientists proposed more ambitious approaches to studying the object, including attempts to send robotic probes for close-up encounters. However, the enormous speed of 3 Atlas and its trajectory made such missions extremely difficult with current technology. Any spacecraft attempting to intercept the object would need to achieve unprecedented velocities and execute perfect timing to match its path, a challenge that pushed the limits of current propulsion systems and mission planning capabilities. The European Space Agency's planned Comet Interceptor mission represented one possible solution to this problem. Scheduled for launch in 2029, this probe would be positioned at a gravitational balance point in space, where it could wait for the next interstellar visitor to appear. Instead of trying to chase down objects after they were discovered, the spacecraft would already be in position to deploy smaller probes for detailed study. But this mission wouldn't help with 3 Atlas. It would arrive too late to catch this particular visitor. The frustration of missed opportunities weighed heavily on the scientific community. If humanity had detected 3 Atlas even 1 year earlier, there might have been enough time to organize a proper intercept mission. Advanced space agencies could have potentially launched probes to rendezvous with the object, possibly even attempting soft landings to directly sample its surface. Such a mission could have definitively answered whether they were dealing with a natural object or artificial technology. Instead, they were left to gather whatever data they could from hundreds of millions of miles away, knowing that this opportunity might not come again for decades. As observations continued and data accumulated, the scientific community remained divided on the object's true nature. Each new measurement and photograph added to the growing database of information about 3 Atlas, but the fundamental questions remained unanswered. The race to study this mysterious visitor was also a race to solve one of the most important puzzles in human history. Whether we were witnessing our first encounter with technology from another world, or simply observing an unusually large and strangely behaved comet from the depths of interstellar space. Thanks for watching another episode. While you are still here, make sure to click the video on your screen for more quality content.